screen, especially when you are dealing with operating system. That should be anything, whether Windows or Linux or anything. The file system is one of the major component. For example, if you can see that Windows file system, you have a C drive, a D drive, E drive. So different type of the drives will be there. We are calling as drives. So here every drive will be consisting of some data, right? So the concept of the file system is, or drives, is majorly we are using to store the data into the particular content. So here in the same way in Linux also we have two types of the file system. One is that ext file system, one is that xfs file system. So these are the two types of the file system it is existing into the environment. So, and not only that one, there is a kind of shared file system. So these and all we are going to be performed practically. So just listen the theoretical part, then we are going to implement the everything into the practical. So shared environment is nothing but CIFS and NFS file systems. So how the architecture will be there? Let me open the image. Just think of that into the Windows environment. If I'm going to the Windows environment, this is your hardware. On top of your hardware, you people are installing the operating system. On top of that, we are creating the drives like a C drive, D drive and E drive. So this one is accessed by the end user. So this is the general way of execution. So let me draft it here. This is your hard disk. So this is your operating system. Okay, so this is your like a C drive, D drive, E drive. So this is the end user. So end user can able to access the particular components. So this end user can able to access the things directly. And here two things we need to keep it in mind. One is that the primary aspect is that into the Windows environment, first we are not selecting any file system type. So we are not selecting any file system type. For example, when you are performing any kind of activity, so usually Windows will be supporting two types of the file system. One is that NTFS and FAT32. So NTFS and FAT32, when you are able to see, that means, for example, if you have a pen drive, you are trying to format the pen drive. On the moment of the time, you can see that NTFS and FAT32, these are the two types of the components will be there into the system. So here, being a end user, we are not having any kind of the option to select the things and all. We need to go by nature. So on the second thing is that most of the times when you are going for expansions, reboot may need. So for example, there is a C drive, D drive, E drive is there. Your E drive is totally full, 100%. So you are trying to expand the file system. If you have a space, means usually we are triggering the expand and we are helping out. But some of the times this expand won't be work out. Nothing but it may ask you to reboot the server. So that leads to the problematic situation. Just think of that. You are running the one production environment. Like one of the weekend, okay, you are doing the some migration activity. So at the time of the migration activity, so what exactly that will happen means, there is a one file system is there, Oracle. So in this file system, you are copying the data. Almost 98% is completed. So rest of the 2% is only pending. So when coming to this action, your file system is full. Means it is going to be full. Otherwise, you sense that the file system is not going to be support. After some certain limit, I need to extend minimum 5 GB. or let it be some 10 GB. 5 GB or 10 GB, I need to be extend at any cost. So once you take a decision, when you're coming to the Windows environment, so if you have a disk means we can go with expansion of that, but sometimes it will require that you need to perform the reboot, and moreover it need to be performed on downtime, because the disk should be idle, then only some of the things going to be expanded. If the disk is a running state or working state, it going to be not work. So that is the reason what the people are doing in Linux environment, how this problem is going to be taken. So coming to the Linux environment, we have a feature. So this is our hard disk. On top of hard disk, I am creating the portion of nothing but these all are called physical volumes. This PVs are we are creating. On top of that, we are creating the volume group. I will tell you why I need to create this much of architecture. So this is a LV I am creating. So the next step is that we are creating the file systems. So then we are going to mount. Let me draft here. So this is our hard disk. So this one we are calling as a PVs. PVs is a nothing but portion of your hard disk. So it is a portion of your hard disk, nothing but how much of the portion it is available. In your black device, it will going to be list you out. Secondary thing is that, so it's the same like your disk, nothing but one is 10 GB is there. Okay, so another one is that 11 GB is there. Okay, so means, so that is depends upon your hard disk. You are segregating the number of parts. Every part we are calling as a physical volume. On top of that, you are creating the volume group. So volume group is nothing but it is a collection of, so the volume group is nothing but it is a collection of PVs, nothing but the combination of the PVs we are calling as a volume group. So this is one of the major components, nothing but PV1 plus PV2 equals to, let it be, this is the volume group. Like a PV1 means this is the one, this is the one, two things I added. Okay, so I have another volume group too. So like a PV3 plus PV4. So the sum total also, for example, if you're coming to here, the sum of the total is the 10 plus 11 GB. It's equals to 21 gigabytes. So this is the capacity of VG1. VG2 capacity is that depends upon the how much of the space we are allocating. Means the combination of the things. Why we need to create a volume group, that we'll discuss. Before that, so we are creating the LV. So LV is nothing but logical volume. So the logical volume we are calling as, okay, so LV is created on top of the VC. For example, here volume group will be act like a your virtual hard disk. So VG is your virtual hard disk. On top of that, you are creating the LVM. LVM is a portion of area. That's the same thing we are creating into the PV. But why we are, what is the difference between the PV and VG means? PV is a raw data. Means we cannot able to store the any content into the raw data. LV is nothing but a logical volume, so it will be user can able to access. Okay, on top of that, we are creating the file system. File system by using the mkfs.ext4 or xfs. So here every LV will be some portion will be there. Let it be, this is a 5 GB, this is a 10 GB. So The VG1 capacity is the 21 GB. Okay, but already I use the 5 plus 10. 15 GB is I'm used. So rest of the space, if you want, means I can dynamically, I can perform the operation, nothing but I can increase the without any downtime. So that is one of the thing. Secondary thing is that, for example, there is no space. For example, there is no volume group, there is no space. In the moment of the time also, I can create a one more additional hard disk. From here, I'm going to increase the things also. So this is also we can able to perform by using the LVM. So what is a major advantage here into the LVM means, first thing is that we can able to perform expansions without any reboot. Reboot is not needed. And the secondary thing is that we are selecting the file system type. For example, whether it's MFS or XFS, whatever it may be, we are selecting the file system type also. So that is also one of the major advantages into the real time. Means when you're coming to the cost, so every file system will be having the very important, nothing but ext4 is one of the file system. Majorly we are using for the purpose of, let me come down. For example, till the RHEL6, right, we have a two types of the components will be there. RHEL6 before, RHEL7 after. So RHEL6 before, we are using the file systems called ext2, ext3, ext4 file system. So the concept is very simple, nothing but they are also using for the storing of the data, but the futures are different. But right now majorly we are using the ext4 only because of it is still having the valid good amount of support. Okay, so it is supporting the concept called journaling. What is a journaling here? Journaling is a nothing but it will audit of your file system. Nothing but what exactly will happen to your file system. What is a server? What is a component? Everything we are going to be identify in that one. So and the secondary thing is that once that is a completed, journaling is completed, then your data will be keep on storing. So the journaling only for the audit of your file system. It is not supporting to the user. It will be the under the control of kernel. So the kernel will be keep on monitoring on your file system like a C drive or D drive. So by any situation your file system is not mounting or it is trying to mount, you are getting the some error. On the moment of the time, so this FSCK we are using. So file system check. On file system type, so it will support this journaling. So means the historical information will be holded by the only this service in the Linux, that is called okay journaling. So once the journaling is completed, okay, so in RHEL7 onwards, the journaling will be up to 16 terabytes it will be there, nothing but so we have a good amount of space. So we are giving the importance to the journaling 16 terabytes minimum quality. So whenever you people are selecting any file system, we have an option whether I can go with a ext file system or XFS file system. Whether which one is need, I'm going to select that one. So this ext file system when compared to the XFS file system is supporting the large portion of virtualization, Dockers and Kubernetes. So advanced features will be supporting. So there is a two types of the file system will be there, NFS and Samba. So these are the we are calling as shared services. What is a shared services means? Whenever you people are performing any kind of activity, if you want to share the data from the Windows to Linux, Linux to Windows, so Unix to Unix environment we are calling as a using the service called NFS. Samba is a nothing but majorly we are using for the CIFS environment. Okay, nothing but Unix to Windows environment. So these are the theoretical part. So when you go into the practically, you people can understand this topic very easily because the terminologies are little bit new. It will be somewhat different when compared to the earlier. So there is a some of the commands at this process we need to know that. LSBLK command. The LSBLK command we are calling as list the block devices. Means what are the devices are there? Everything it will be listing out. So let me start the server. So let me show you practically what are these commands and all. So we have the sum of the commands. So when you go into the diagram representation, so to know that which are the, this is your hard disk, to know that which are the PVs are there, we are using the PVS command. If we are to know the which commands are we have VZ, like that every stage to verify each and everything we are using the sum of the commands. So let me go with that IPR. This is my server. I'm using the one command called LSBLK. So the LSBLK command, it will help you out list the block devices. For example, what are the hard disk or any raw disk available into the my server, LUNs or whatever it may be. So we are using fdisk-l. So we are using the command called fdisk-l. So the fdisk-l command will help you out full-fledged information of your raw disk. For example, there is some information you want to list out, full-fledged everything it will be list out. So this is the shortest information of your raw disk information, and fdisk command will give you the full-fledged information of your disk information. So once it is listing out, for example, next component is that I need to know that what are the PVs are there. So we are using the command called PVS. So the PVS command will list out the physical devices are any there, PVS. Same command PV display. So PV display command will give the information of additional information of there. For example, if any PV is exist, so the property information of the PV, nothing but full-fledged property information. What is the size, capacity, and unique number? Everything it will going to be listed out. And after that, VGS. So VGS command will give the information of volume group information, and VG display command will help you out the full-fledged information of your volume group. So this is the way how it will going to be listing out the content. Same way LVS command. LVS command will list out the information of your logical volumes, and LV display command will give you the full-fledged information of your LVMs. And after that we have two more commands, MKFS, and these are the things we are directly using these commands. So everything, so in your shared environment we have these nodes also, we have nodes also, just go through the nodes also. Okay, so let me take you the one example. So we have a one scenario. I need to create this setup. I need to create the setup of this one, means I need to create the one LVM file system. So usually we are receiving the request in such a way that, so the request will be, so we need to create a 5 GB LVM with the name of /app on the server particular and the file system type. So you will receive this kind of the request from the user by generally. Once you receive the request, automatically we are going to perform the action, nothing but, for example, once you receive, first of all we are going to validate whether we have space into the volume group. So volume group we have a space, I'm going to validate. I don't have any space into the volume group, so I am going to validate whether we have any space into the volume group. So right now it is not showing any space into the volume group. So I need to request for the new storage device. So the new storage device I'm going to check with everyone. So first storage team. I will send a mail to the storage team. Usually every company will be having the one architecture. Some of the companies they will raise the ticket and some of the companies they will send the request to the storage team. So we need a request to the 5 GB of storage device. How much of the space you need? You need to mention that space content. So 5 GB of the space you are looking for. And meanwhile, how much of the content you are going to be looking from, whether it's a VMware team or storage team, whoever it may be. Once you raise the request to the storage team, automatically the storage team will create the storage device. But usually they will ask you that which servers you are looking for, and whether it's a production environment, stage environment, test environment, which environment, and the DC type, data center type also it will ask you, and the size of the file system also ask you, nothing but how much of the size it is looking. So in this process, once they created, they will share the details to us. So from operating system side, so we requested and operating system side they confirm that they added the 5 GB. So how they are going to add it? Since it's a test environment, we only need to add. Right click on this one, settings, select the hard disk, add, let it be some 5 GB, right? So I'm adding this 5 GB. Click on OK. So whatever that I'm discussing, we have a document. This document is already added. It is already shared to you people on the folder of LVM. So this is the scenario right now I am performing. Okay. So how to add a disk? This is the disk I completed. Nothing but usually this part will be taken care by the storage team. But the thing is that into the real time we are only performing the action since it is a test environment. So from this I'm going to perform the kind of the action, nothing but so we are going to scan the devices. Why means, for example, when you trigger the lsblk command, I'm not seeing the any new disk. Means this disk is already allocated, it is a working, and this disk is not the 5 GB one which I requested. Means it is not listing the your storage device. So automatically what we are going to do it, we are going to refresh the content. So this command what exactly it will do means it will refresh the content of the your storage disk, means 5G. The storage disk will be listed out here and you are able to perform the actions on here. So the 5 GB disk is going to be listed out, and immediately once it is done, then we are going to the next level of action. So now the storage device is created. As per the diagram, storage device is there. So I need to create a PV, I need to create a VG, I need to create a LV, file system I need to create, mounting I need to do it. Totally 5 steps we need to do it. So how to create a PV? So creation of the PV by using the PV create command. Okay, so it's very simple. PV create /dev/sdem. Why I need to give the dev means all the raw disk information will be there into the /dev. So /dev is under the control of root file system. It is operating system control. So that is the reason /dev we need to give. Automatically everything will going to be existed. So PV created. PV scan is one of the command just to scan the or refresh the things. Let me trigger the PVS. So earlier this 5 GB was not listed out, but right now this 5 GB is listing out. So this 5 GB is listing right now. So once this 5 GB is listing out, I can able to perform the other set of action. For example, now PVS I created, I need to create a VG. VG create VG hyphen data, VG name. Okay. So where I need to create, so I need to create a SDA. So this is a VG scan. So VG scan, PV scan, LV scan, these all are commands we are using to just to refresh. Okay, there is no kind of the any loss of data or anything will be not going to be happen here. Okay, so now VGS commands are declared, and after that, okay, so now I'm going to reset nothing but I need to create a LV create hyphen L is nothing but length. So L is nothing but length. Let it be 5 GB. I need to allocate 5 GB. I need to allocate. So on top of the 5 GB, some so I'm using hyphen N LV hyphen data. It's a logical volume name. We call LV hyphen data. So on top of that LV hyphen data, VG hyphen data. So VG-data is nothing but you are creating the disk on top of the LV. You are creating the LV on top of the volume group. So here the entire 5 GB is not available. Let me give the 4.9 GB. So LV created. So the rest of the 1 point is allocated to the your buffer space. So that buffer space will be by default automatically it will take you. So whenever general is calling or whenever someone is trying to reach out particular disk level and all, automatically it will be list out the information. So LVS it is a list out. So go with the LV display command. Why I need to go with the LV display command means after LV I need to go with the file system creation. So file system creation if you want to do it means mkfs.ext4. Okay, so with the file system type, so 4 is I selected and I'm going to select the file system path. If we need that path means we need to go to the LV display. So I'm going to the LV display. Okay, if you can see that LV data is the one which we are creating right now. If we are already aware of that means mkfs. So this is the command, the same command. The above command what we done, we displayed everything. But in production environment, it will list you out more than a 10 to 15 lines of the code, everything. Because here it's a tested environment, we are having the only one LAN. But when you go into the production environment, okay, it will going to be lot of consumption will be there, nothing but lot of disk will be there. So that what we are going to do, it means we are going to perform the disk by using the gripping the device. So mkfs.ext4 file system I created. So file system created and mount is the one of the disk, mount source space, and the app is the particular thing user asked that. So for that reason I need to create a one directory. So right now my directory is already existed with a slash app. So that is the reason I am not adding anything. So df-th slash app. So this is a way we can able to create a disk. If you're coming to the architecture wise once again, first we got a raw disk. On top of that we are creating the PVs we are creating. On top of that VG, on top of that LV, on top of that everything we are creating. So this is the architectural view of your LVM. So any doubts till now? So we have a notes, just you need to follow the notes also enough, but you need to understand a little bit the concept. So this is one of the important one. So that is the reason I'm expecting, maybe you can try first. Okay, because after implementing only, okay, then we can go to the rest of the scenarios. Because the rest of the scenarios are somewhat advanced level, maybe file system is not there, expansions or coordination, this type of the activities will be there. So just you practice this one for a while. Okay, then you people can understand what is a PV, what is a VG, what is a LV. Okay, the content already there, just go through the content. Okay, so hope you people can practice for that. సో వైష్ణవి అర్థమైందా?
Yes.
ఎందుకంటే ఇది
Yes, sir.
ప్రాక్టీస్ చేస్తేనే కొంచెం మీకు అర్థమవుతుంది. దెన్ వీ హ్యావ్ అరౌండ్ 8 scenarios are there. We have different type of issues. For example, how we are managing our C drive, D drive, V drive. In the same way, we are managing this file system. Sometimes your file system will be corrupt. Sometimes you need to repair it. Sometimes you need to change the file system architecture. Everything we can able to perform by using these commands. Different scenarios. It will take at least 3 days only for the LVM. This is one of the very important topic into the file system level. Okay, just do practice this one alone today. I will share you the video. Okay, so rest
Sure.
you can do the follow, because I don't want to be continue by simply. I can continue from the myself, but you need to understand that is what. Just go through the thing, simply complete this task, creation of the new file system. Okay,